Hello, welcome to Engineer's Mindset. So let's consider the question on the board. It says, if A, B, and D are vectors, prove that A plus B plus D equals A cross B plus A cross D. Okay, this is actually a distributive law of vectors. So let's try to prove this law and see. So to prove this law, we are simply going to attach the values for the vectors A, B, and D. So you can simply say, let A be equal to I plus J plus K. D equal to, say, 2I plus 2J plus 2K. Please take note, you can use any figure you want. You will see arrive at the same answer. And let D be actually 3I plus 3J plus 3K. So we have these three values. So we want to now prove this. Let's start with the left hand side. We start with B plus D. B plus D is simply add vector B and add vector D together. Vector B gave us this. So this is actually equal to vector B is 2I plus 2J plus 2K. So we are simply adding vectors D to it. And vector D, we said we use 3 all through. So we simply have 3I plus 3J, okay, plus 3K. Alright, therefore B plus D is now equal to, of course, vectors can only add when they are moving in the same direction. So I have 2I plus 3I, they can only add. But I can't add 2I to J, I can't add I to J, I can't add I to K. They can only add when they move in the same direction. So I can only add I to I, J to J, and K to K. Alright, so 2I plus 3I simply gives us 5I, okay, plus 2J plus 3J simply gives us 5J plus 2K plus 3K simply gives us 5K. So we have this to be B plus D. Now, next thing to find is what? A cross B plus D. Okay, so we simply find the cross product of vectors A with B plus D. So we are going to use matrix to make this easier. So this is now equal to, let's use matrix now, determinant matrix. So I simply have the first column becomes my I. Okay, next is J, and then next is K. So I'm having vectors A crossing B and D, B plus D. So starting with vectors A, the component of vector A simply means is I, J, and K. So their coefficient is actually 1, 1, 1. So I simply have A, 1, 1, 1. Okay. The next is what? Vectors B plus D. B plus D gave me 5, 5, 5. Okay, 5 for I, so I'll simply have 5. Then 5 for J, 5. And then 5 for K, 5. Okay, so I have this. So using the matrix makes it easier. Okay. Now for the vectors, using matrix, the first is positive, next is negative, and this is positive. So we're not going to break this into determinants. We learn for the determinant of this matrix. Okay, so this is now equal to, I will start with I. So simply what take out I. Now you block, since I'm starting with I, block this row, block this column. I'm simply going to be left with what? 1, 1, 5, 5. That becomes a 2 by 2 matrix. So I'm starting with I, so therefore I will simply block these points and block this row, the row and columns. Okay, so I will simply be left with what? 1, 1, 5, 5. So I'll simply have I into 1, 1, 5, 5. Remember, it was positive, so the first is always positive. Plus, the next is what? Negative. So I'll have negative and I'll have J at that point. So negative and then that column is simply what? J. Now, since I'm at point J, this is what I will do. I will block the row of J entirely. So block this point entirely, block the column of J as well entirely, block the column of J, block the row of J. So I'm left with 1, 1, 5, 5. So you block this point like this, I'm left with 1, 1, 5, 5. So I'll simply also have, open here, 1, 1, 5, Finally, we have positive cross. Okay, and then the next is K, positive K. So open the determinant. Okay. So since I'm at K, block the column of K entire, then block the row of K as well. So this is off. So we are left with 1, 1, 5, 5. So we have 1, 1, 5, 5. Alright. So having done this now, let's now take our determinant. Okay, so determinant is simply what? Measure multiplication of the major basis minus multiplication of the minor. This is called the major line. So 1 times 5 minus 5 times 1. Okay, so we simply have I into 1 times 5 into the major, 1 times 5 minus minor, which is 5 times 1. 5 times 1. So I have this. Okay, minus j into also major, 1 times 5, 1 times 5 minus 5 times 1. 5 times 1. Okay, so I have this plus k, which is okay, into major 1 times 5, 1 times 5 minus 5 times 1, which is minor 5 times 1. Okay, so I have this. Alright, so I'm going to have that A cross B plus D is now equal to, of course, 1 times 5 is simply 5. So I'll simply have I into 5 minus 5 minus j into 5 minus 5 plus k into 5 minus 5. Okay? And of course, A cross B plus D is actually going to give us 0 because this is I into 0. Plus minus j into 0 plus k into 0, and everything automatically gives us 0. So I'll simply have that. Okay, that's simply that A cross B plus D is actually what? 0. Alright, so having done this is the left hand side of the equation. So it means the left hand side is 0. We will now work on the right hand side and see if we obtain 0. If we obtain 0, then it means our result was accurate. Now the right hand side says, first of all, let's find A plus B plus B plus A plus D. Okay, so the right hand side says, first of all, find A plus B plus A plus D. So we're going to now find A plus B and see what we're going to have. Okay, so let's obtain A cross B. So let's also use matrix. Okay, we'll have positive, negative, positive. This becomes I, J, and then K. Okay, these are bars. Now, vector A is simply I, J, and K. Their coefficient is simply 1, 1, 1. So we have 1, 1, 1. Meanwhile, vectors B is simply 2i, 2j, and 2k. So their coefficient is simply 2, 2, 2. Under I, we have 2. Under j, we have 2. Under k, we have 2. Okay, so same thing applies. This is now equal to, so starting with I is positive. So you simply have plus I. And since we are on that column, simply block the row of I and the column of I. We are left with what? 1, 1, 2, 2. So block this row and the column of I. We are left with 1, 1, 2, 2. So we have 1, 1, 2, 2. We have this. Next is after positive, we have negative. So we have negative j. That is column j, which is this. Okay, so we have our determinant bar. Okay, so we block the column for j and block the row of j as well. So this is off. Block the column, block the row. We're only left with 1, 2, 2, 2. 1, 1, 2, 2. Okay, so we have 1, 1, 2, 2. Finally, it's plus k. So we have plus k. Your matrix bar. Okay. Okay, so block the column of k. Block the row of k. Okay, the row and column of k completely. we're left with 1, 1, 2, 2. If we block the row and the column, we're left with 1, 1, 2, 2. So we have 1, 1, 2, 2. Okay, so we have this. Now let's evaluate this and see. So we have I into, of course, I said multiply the measure together minus the minor. Okay, so this is 1 times 2, which is the measure, minus the minor is equal to 2 times 1, 2 times 1. Okay, minus j is same thing, 1 times 2 is the measure, 1 times 2 minus the minor, which is 2 times 1, 2 times 1. Finally, plus k into less is also measure, 1 times 2. We have 1 times 2 minus 2 times 1. Okay. So this is actually what I into, this is 2, 1 times 2 is 2, 2 times 1 is 2. So you have 2 minus 2 minus j into, also 1 times 2 remains 2, 2 times 1 remains 2, so you have minus 2. Okay, plus k into 2 minus 2. Okay, so this is now equal to I into 0, plus 2 minus 2 is 0, plus minus j into 0, plus k into 0. So that simply implies that A plus B is actually equal to 1 by 0 is 0, j by 0 is 0, everything here gives us what? Simply 0. So we'll keep this aside. So A plus B is actually 0. Next thing to find is what? A plus B. Okay, so let's find A plus B. Not forgetting that we have A plus B will be 0. So let's put that down here. Remember we have A plus B plus D actually give us what? 0. So we want to prove this now. So let's take this side off. Okay, so the next thing to find is simply what? A plus D. So A cross D, also using matrix. This is plus, minus, and plus I, J, and K. Okay. The values of vectors A remains I, J, which is 1, 1, 1. That's our question. So we simply have 1, 1, 1. Meanwhile, the values of vectors D is simply what? 3, 3, 3. So we simply have 3, 3, 3. Okay, so you have this. Now we apply, of course, the rule of determinants. This is now equal to, starting with positive plus I. Okay, we have block the row of I, block the column of I. We are left with what? 1, 1, 3, 3. Block the row of I and column. We are left with 1, 1, 3, 3. So we simply have 1, 1, 3, 3. Okay. Next is minus. So we have minus j. Okay. So block the row of j entirely. Block the column of j. You are left with what? 1, 1, 3, 3. So block this row. Block the column. You are left with 1, 1, 3, 3. So we still have 1, 1, 3, 3. Finally, what? Plus k. Okay. Plus k, also block the row of k, block the column of k, while left simply 1, 1, 3, 3. Block the row and the column of k, while left with 1, 1, 3, 3. So we simply have 1, 1, 3, 3. Okay, so you have this now. Now let's evaluate. This is now equal to I into measure, which is 1 times 3, minus the minor, which is 3 times 1. Okay, minus j into also measure 1 times 3 minus minor 3 times 1. Okay, finally plus k into measure 1 times 3 minus the minor is 3 times 1. Okay, so you have this. Now this is now equal to I into 1 times 3 is 3, minus 3 times 1 is also 3, minus j into 1 times 3 is 3, minus 3 times 1 is also 3, plus k into 1 times 3 is 3, 3 times 1 is also 3. Okay, so this is actually what? 3 minus 3 is 0, so that's I into 0. minus j into 0 plus k into 0. So this simply implies now that A itself cross D is actually what? 0 minus 0 plus 0, which is actually what? 0. So if we know A cross B and we know A cross D, the law is simply saying that A cross B plus A cross D must be equal to what? A cross B plus D. Okay, so A cross B plus D gave us 0. Now let's also check if A cross B plus A cross D will give us 0. We have that A cross D, okay, plus A cross D is now equal to, which is right hand side of the law, A cross B plus A cross D, and we obtain A cross B at 0. So we simply have 0 plus, we also obtain A cross D at 0, which is here 0. So this simply means that A cross B, okay, plus A cross D is actually 0 plus 0 also gives us 0. Now, since the left hand side, which is A cross B plus D, is equal to 0, and then the right hand side, A cross B plus A cross D equal to 0, it means the two are equal. Therefore, the law exists. Hence, therefore, A cross B plus D is equal to A cross B plus A cross B. So we simply say the law exists. Alright guys, that's how to prove the distributive law of vectors. Okay, I will see you in the next video with more wonderful questions on vectors. Thanks and cheers.